The next part we're going to take a look at is calculating probabilities of complements. We have a table shown here that shows the number of students that are in a study hall of 25 students studying a foreign language. And if we select a student at random, we want to know the probability that the student would not be studying a foreign language. The first thing that we need to do with this is total up how many total students we have that are working here and on foreign language. So 6 plus 12 is 18. 18 plus 3 is 21. That means that if we were to have the probability of someone studying a foreign language, that would be 21 out of 25. But because we're looking at the probability of not a foreign language, and that little swirly do represents not, we're going to take 1 minus the 21 out of 25, which means that 4 out of 25 possible students would be not studying a foreign language. If we take a look now at this problem, we have students receiving a 5-digit locker combination. What's the probability of receiving a combination with all odd digits? The first thing we need to do with a problem like this is determine if the code is a permutation or combination. Now, despite the fact that we call it a combination, it is actually a permutation because order does matter, because if I do 6, 16, 6 for like a regular locker combination, or 6, 6, 16, either way, those are two different locker combinations. My second step then is to find the number of outcomes in the sample space. Well, because we can repeat numbers, I'm going to look at it as we have 5 digits. And we can use the numbers 0 to 9 for all of these digits, which means that I've got 10 possible options of numbers to use each time. So that means if I take 10 to the 5th power, that means that I have 100,000 possible options. So then the next piece is going to be to find the number of favorable outcomes. Well, we still have those 5 slots, but now we're talking about only odd numbers. So that means 1, 3, 5, 7, 9. So I have 5 possible options for my combination. So if I come over here and take 5 to the 5th, I get 3,125 possibilities. So then I need to put that into a probability, which means that I have 3,125 possible combinations out of 100,000 that have all odd numbers. If I simplify that fraction, they're both divisible by quite a lot. We get all the way down, both divisible ironically by 3,125 to get 1 out of 32. So that step we missed was finding a probability. So then I want to take a look at this table, using a table to calculate that experimental probability. So we know that this totals out to be 50 times because it tells us in the problem. So spinning a 4 is dealing with that 14. So I have that 14 out of 50 possibilities is going to be spinning a 4, which simplifies to 7 out of 25. So every 25 spins, 7 of them should be, according to this table, a 4. Now spinning greater than 2, that's going to deal with both of these. 19 plus 14 is 33. So that means that 33 out of 50 chance is going to be spinning a number greater than 2, and that cannot be simplified. Your job now is to go ahead and try the U-Try problems. Give yourself a chance to calculate these. Bring any questions with you to class tomorrow. And have a good night.